For this particular problem, we have our square roots by themselves on opposite sides of the equation, or the equal sign. So we can square both sides right away. The square and the square root will cancel each other out, and you get x squared minus 3x equals, and here the same thing happens, and you get x plus 21. Now I notice I have an expression with an x squared in it, so I need to get 0 on one side. So let's subtract x from both sides. Subtracting x here, I get a negative 4x, and subtracting x here, this disappears to leave me with a 21. Now I'll subtract 21 from both sides. Subtracting it over here gives me x squared minus 4x minus 21, and subtracting it here gives me 0. We can now factor this. Factors of negative 21 that will add up to a negative 4 are negative 7 and 3. So this will be an x minus 7 times x plus 3 when it's factored. Now, either this equals 0 or that equals 0. So we have a possibility of x minus 7 equaling 0, or x plus 3 equaling 0. Here, if you add 7 to both sides, x would equal 7. And here, if you subtract 3 from both sides, x would equal negative 3. We have two possibilities. We need to check both of them. Let's check both of them in our equation. We'll start with our x equals negative 3, replacing all of the x's with negative 3. So we get square root of negative 3 squared minus 3 times negative 3 equaling square root of negative 3 plus 21. Over here, negative 3 squared is 9, and negative 3 times negative 3 is 9. Over here, negative 3 plus 21 is 18, and when I add those, I get square root of 18 equals square root of 18. That's true. So the negative 3 worked just fine. Let's check our 7 here. Our 7, replacing each of these x's with 7, will be square root of 7 squared minus 3 times 7 equaling square root of 7 plus 21. 7 squared is 49. 3 times 7 is 21. That's going to equal square root of 28 over here. Here, if we subtract those, it's square root of 28, which equals square root of 28. And that's true, so our solution set is the set of negative 3 or 7.